Hi everyone, glad to have you back here. If you're if it's your first time, hi, I'm Akriti. I work as a data analyst in an AI solution startup. And once I'm done working, I come here on social media, primarily Twitter, and now on YouTube as well to share whatever I've learned so I could make your journey easier. Thank you for joining me here. This is 15 days of SQL where every day for 30 minutes, 40 minutes for the next 15 days, we come here together and learn on this live stream. And I hope this will add value to your data analysis journey. SQL is one of the most important concepts, and I cannot stress on this enough that how essential it is to your career, no matter if you're pivoting from some other domain or just getting into this, you're a fresher, or you just want to start learning and getting into data. No matter what your role is, data analyst or data scientist or data engineer, SQL is your go-to. You cannot go around without SQL because since you are in the data domain, you have to access the database. And how would you access the database? Is using some or the other kind of SQL. So if you're here today, I am so proud of you. Half of the work is just showing up, and I'm so glad that you've done that. Let's get ahead. Now the easier part, which is just learning and practicing, which we'll do here together. Let's get started then. I hope I am clear and the screen is proper. If it is not, please can one of you let me know in the live chat. The tutorial I'll be following is from Mode. I highly recommend this platform since it has very well written blogs and practice problems. The better part of it is the practice problems because I just don't want you to read blogs and get theoretical information out of it. I want you to get hands on, and this is what this platform facilitates, all for free. So I love this, and I have added the link in the chat box. I would want you to open it and try it yourself. Now, what we're learning today is joins. And what do joins do? Well, joins are SQL's way of trying to get fetch data from a relational database. And what is a relational database, you ask? So relational database is a set of different data sets which are stored together in such a way that they have some relation between them. So each table is related to one or other tables in some manner. Some property inside every table is related to other table. Okay, be it, for example, I want to see what is a student. Okay, there's a student table, and so every semester, whatever class they are taking, who is teaching that class, I will just add that teacher's ID number there. Okay, so this student is being taught by so and so teacher. Instead of saving the entire information of that teacher, where they are from, when they have started school, what is their specialization, how much experience do they have, what is their pay, which department they belong to. Instead of storing all of that and cluttering our student database, I'm just giving the teacher ID in the student database. And I am linking that teacher ID to my existent teacher table, which has those IDs, and it has, against every ID, it has the equivalent teacher information present. That helps in, first of all, organizing the data better, and context switching is not as much. The data is cleanly stored, and you can get whatever data you want to by either joining, or if you want just the student specific data, you also have a way of doing that. Second thing is your queries are faster since they have to operate on way lesser amount of data, since once they only have to consider so many tables and not the entire database on its own. So these are all of the benefits that we have. Now I'll be giving you Let's get started with joins. Joins are generally very derided as the most difficult, complex topic in the data community. So let's try to demystify it in a simple, no-nonsense fashion. This is a visual representation of what joins do. So if you are not very well equipped with these Venn diagrams, they are just a mathematical operation, a function where two different circles represent two sets of data. So here it is a table itself. So each circle here is a table. Now when we are joining, what are we joining? When we say left join, what is it? We'll see in just a while. We will get all of the table in A, all of the data in table A, and whatever is common with B. Then when we say right join, so we'll get the right table, all of the data in B, and the common data with A. When we say just inner join, we only get the inner common part. When we say left join without this thing, there's some condition which we'll look into later. This, what it does is it just gives us the A data, removing whatever is common with B. So it is an equivalent to the minus operation. Same with right minus, when you do, you'll get B, and whatever is common would be deducted. There is this full outer join where you can also perform. First, you'll get all of the table data from both of the tables and the common part, and then there's a way to remove that common part. If all of this was too much at once, don't worry, we need not care about it. We'll take it one join at a time. Now, let's think about just join. Okay, what join does is it maps two or more tables together on the basis of some condition. That condition would be the relation which is present between the two tables. So in my example, my relation was that each student has some teacher ID, whatever class they are taking. So in their row, whichever class they are taking, they have the teacher ID with it. And that teacher ID is the linkage between the student column and the teacher column. That teacher ID is one amongst the many teacher IDs present in the teacher table. So on the basis of that condition, the relation between those two tables are how we perform the join. Join is just a way to get the data from both of those tables based on some condition. So whenever I'll say that if I want to know what is my student's teacher, what is the details of my student's teacher. So I'll say wherever this particular teacher ID, which is present in my student database, hits or is equal to the teacher ID among the full table which we have for the entire teacher database, wherever you find that one teacher ID amongst the many IDs present there, you extract that row for me and join it with my student row. What I'm doing again, I'll explain. That wherever you find the teacher ID which is given for my student, so my student has certain classes ahead, and who is teaching that class is also stored in that table. So we have certain teacher IDs, and if I want to know more about that teacher, what I'll say SQL to do is that this teacher ID you take, and this teacher ID wherever it is present in my original teacher table, you give me that row, the entire row, and join it with this result and present it to me. That's the basic function of join. The syntax is to give table 1, join, the keyword join. As I specified earlier in the previous video, that today we'll just be dealing with the from clause. Till now we were certain where our data was present. Now we need to get data from multiple resources. So what we would be altering is the from clause, because from is what specifies where the data is stored. So we'll edit the from clause, and what we'll do is, earlier till all you had was from table 1, but now since you need to get it from another table, you will add this join, the keyword join, and then you'll give the name of table 2. After that, you would have to specify on what condition. Okay, there's some relation between those two tables. What is that condition? We'll say on, and then we have to say whether this column is equal to some column inside the second table, or it is lesser, or it is kind of in the same pattern. Whatever you can do, you know how to construct certain conditions based on what you want. If you have not checked that video yet, you can go back in this playlist, and there's operators and comparison operators, logical operators, pattern matching, which we have dealt with earlier on, which all focused on what are conditions and how you can apply those conditions in order to filter data according to your needs. So that knowledge is what we'd be applying here, and we'll issue a condition which is nothing but the relation which the data must follow. That condition in this case is that the call name for table 1 should be equal to the call name of table 2. So how you access different columns from when you have multiple tables is using the dot operator. So we'll write the table name dot column name. Okay. I hope this was clear and not too much theory. If it was, it won't be anymore. Okay. So I would request you to click on the tutorial which I have sent you and start practicing. Okay. Oh, where is my table? Mod SQL and joins. Here we have it. And the practice problem which I'll be dealing with is this one. Write a query that selects the school name, player name, position, and weight for every player in Georgia, ordered by weight, heaviest to lightest. Be sure to make an alias for the table and to reference all the column names in relation to the alias. Of course. So what they meant is, you know how sometimes you give alias to a new column when you have a derived column. Remember, we have used arithmetic operators to create new columns. In the previous lecture, we used case to create a new column based on conditions that the data should follow. So whenever we have a new something, we need to give it an alias in order to access it. Okay? Those alias can also be used to shorten the name of certain tables if they're too huge and you don't want to use them again and again, since we know that we'd be using our table names a lot, table name dot column name. So to shorten the name of the tables, we use alias. How? We'll see in just a minute. And what is we are using Ben college football teams and Ben college football players. Okay. And what do we want? School name, player name, position, and weight for every player. Okay, where is that data stored? Let's see. First, I'll see how is the data like. If this is your first time writing an SQL query, select as used to pick certain columns which we want. If you're using an asterisk, this is a way to tell SQL that you want all of the tables, all of the columns present in that table. And now I have this table here, then college football players. So this has the school name, player name, position, height, weight, year, hometown. Okay. So what they wanted was write a query that selects the school name, player name, position, and weight. So we have school name, right? Now that we want specific columns, we would have to specify in the select clause. So we want school name, we want player name, and we want position. Next, what do they want? School name, player name, position, and weight. So weight. Okay, all of this we want. Now what else we want is for every player in Georgia. Okay, what is the code for Georgia though? I don't know if there's someone. from America in the live stream, please let me know or I'll Google it. So as a data analyst, as anyone in the software industry, you'd have to Google a lot. Don't think you're cheating or doing anything bad just because you're copying. So yeah, I just searched Georgia state abbreviation and it's GA. So let's go. What we'd be doing is, since we want only for the players in Georgia, we'd be putting a filter. What is that filter? That filter is state should be Georgia. And how would we translate in SQL language? That is, we'll give the column name where the data would be stored and we'll compare it to a value which we want, which is Georgia. What this condition would do is, whenever the state is Georgia, it will select that row. Whenever it is not, it will discard that row. Okay, states are saved as abbreviations. So I wrote the abbreviation for Georgia, which is GA. What else do we want? Ordered by weight. Heaviest to lightest. So heaviest to lightest means that we want descending order. I'm using 4 here because weight is the fourth occurring column in this list. So to save myself time and type less, I'm using this one to, I mean, you can use numbers to reference columns by their order of occurrence in the select query. Here weight is the fourth column, so I'm using 4, so it will say order by weight. And how do I want it? I want it in the descending order. If I wanted it in the ascending order, I would have left it at that because order by is ascending by default. But I wanted it to be descending, so I am doing this. Let's see if it worked or not. And I'll show you that there'll be some difference between my query and their query. What is that difference? Let's see. They're using alias. What is that alias? So instead of taking this whole big name called Ben college football players, I can just use P. Okay, P. P is the name which I'd be using. So when I say, I type a space and whatever I write after it is considered as the alias or as a second name for that thing, for that table. So now Ben college football players can be replaced with P whenever I want it. This is very useful when you have multiple columns which have similar names in multiple tables. So for example, if I had student name, okay, so there was name column in my table student and I also had name column in my table teacher. So how would I tell SQL which one of the two names I want? So I would have alias and I'll reference using that alias and a period that I want s dot name, which is students. I would declare my alias as from students s. So I'll say s dot name or t dot name if I want the name of the teacher. This is how you use alias. You add a space, right? It can be anything you want to give it, your choice, and then you'd have to use it to specify which column you want whenever there's a ambiguity in column name using the period. So you can use alias like this. It won't affect the query now since we only have one column. Oh, p dot school name. It did not like my alias apparently. Yeah. So why is it not taking my alias? Let's find out. P dot. Now it is working. Earlier it was not working. Why is that? I don't know. You see, now the same thing, same query is working, but earlier it was not working. Editors are crazy. Not the writing editors, the code editors. Okay, that was chaotic. I'm sorry about that. Let's move ahead to our next problem, which is using now actually two tables and joining them together using our on clause. So, oh, I'll give you an example. So, see here. You have everything about that player. What is the school name, player name, position, height, weight, your hometown, everything is present here. Then you want to know more. So what you do is you join another thing, which is something from our teams. So what teams has extra is some sort of column. Here the column is school name. No, yeah, the name of the team. That is what would be added. It is basically a way of getting data from other tables and joining it based on our conditions. Now, oftentimes what happens is it's always not possible that your conditions match, right? Maybe I have a teacher ID which is not present in the database at all, in the teacher database. It's a new teacher and the data table has not been updated yet. Or what happened was, okay, most of the teachers were teaching classes, but not a lot of teachers were selected, like matched the condition for when mapping them with students. So what would we do with those redundant rows which did not match the condition? What do we do with them? The way you write your join query tells how you treat them. So if you say inner join, if you specify inner, what inner gives us, we have a very beautiful Venn diagram here. Inner will only give you the common part, which is wherever the conditions match. Wherever the conditions don't match, that part would be removed. So you see, you'll only get the blue part here where both of the tables A and B are overlapping. You won't get the white part where the conditions are not satisfied. Okay, that is called inner join. Inner join eliminates rows on both tables that do not satisfy the condition, which is specified in the on clause. Okay, let's practice it. This is the tutorial for inner join. Feel free to post your queries in the chat box. I am looking at it frequently. Okay, again, they have also given the same very Venn diagram where you have two tables, table 1, table 2, and what you get from your inner join is their intersection, wherever both of them are present. In other words, wherever the condition strikes or is satisfied. In this case, what is it? That the school name from the teams table is equal to the school name from the players table. Wherever that matches, those two columns for some row matches, those rows are joined together and presented to you under the query result. Wherever that condition is not true, some school names for which the players were not listed or some players for which the teams were not listed, all of those left out rows, left out data points are not included in your query result when using inner join. Okay. Let's write a query that displays player name, school name, and conferences for schools in the FBS Division 1A teams. Oh, that is a lot. I mean, nothing is a lot as long as it's practicing, but it just felt like a lot. Let's use this. Okay. So we have players and we have something which we'd be constructing. You want player names and players and teams. So I want to know where this conference table actually is. So I'll first look at my data. Okay. Don't mind me doing a little exploratory data analysis. Oh, we have FPS Division 1A team, whatever that was specified as under the column division. So don't get overwhelmed with the practice problem like I did. Look through the data first and you'd be able to make something out of it. And we know that the school name was present in our players table as well, and it is present in this teams table as well. So we know that these two have some relation in between them. What that table has is the information for all of the players. And so, as a part of that information, it has stored that which school do they go to. This table teams has the information that which team is participating from each school. What is its name? Where is it going for the conference? So, as a result, they also have the name of the school. When you're mapping, school name is the column which you should be keeping an eye on. What else? I don't think we have anything else. So what we'd be doing here is we will write our table, which is the name of my first table. And I only want the things that match. I don't want the things that are not matching, because I have a condition here which is FBS Division 1A teams should only be present. So I know that since I need player name, school name and conferences, which was not a part of the original players table which we saw earlier in the previous question, we know that we'd have to use join and join two tables together. Those two tables, what are those? Those are players and teams, because teams has that conference table column. So we'll be using the another table name which is Ben college football teams. Okay, and now we will be giving it a condition. The condition is that the school name from one table should match the school name from the second table. Now here both of them have the same column name, but maybe other times they won't have the same column name, like it would be teacher ID in the students table and it will be just ID in the teachers table. They might not have the same name, but it does not matter. You would have to just give a condition based on what you get. So now since both of them have the same name, how would I specify which table you should get and what you should compare it from? For that, I need an alias. That alias here would be Ben college football players P. So P would be the alias for the players table and T would be the alias for teams table. How do we define an alias? It's by putting a space in front of our table name and writing whatever we want to name it. Give the name as the alias. Now I know that I want the table name, column school name from my players table to match with the column school name from my teams table. So I'll say P dot, what is P? P is my players table, and then I'll write its column name, which is school name. I'll give my condition that I want it to be equal to what? The teams table T, which I'm referring to an alias. Otherwise, I would have to write this whole name again and again, which I don't want to do. If you want to, you can continue, no problem. And I'll say T dot, what is? School name. So school name column from the table teams. This is how I'll join those. Wherever the both school names from both of the tables match, those two rows would be concatenated together. And what are the things which I want? Player name, school name, conferences. Okay, so player name is present in the table players, so I'll say P dot and I'll say player name. Next, school name can be from either. I'll say okay, from player only you get the school. It'll be same for both. Next is conference. So conference is not present in the player table, it is present in the teams table. How will I refer it? I'll say T dot conference. Okay, these three were required: display player name, school name, conferences. And there was one little filtering condition, that the schools in the FBS Division 1A teams, this is what they want the filter to be. How do we give filters? Oops, sorry. How do we give filters? We give filters by the where clause, where we specify a condition. The condition in this case is filtering the division. Where is that division? Division is in the teams column. See, so t dot division equal to what? So FBS division A1A. That was what was specified. And since I'm giving an outside value, I have to enclose it within single quotes and specify that it is a string. Okay. If this was too much to digest, please let me know in the chat box and I'll explain it again. I wouldn't want you to get nothing out of these 30 minutes. So tell me if the pace was too much or there was too much overload of data, and I'll adjust this session accordingly. So see, we have our player name, school name, and their conference, which we got from another table. And that conference was wherever the school name matched, we got the conference part from the other table based on that condition. So their corresponding conference was taken here. And that's how we did the inner joins, where only what inner join does is inner join only takes the rows where the condition strikes and leaves the rows where the condition does not strike. The exact opposite of this is outer join. What outer join does is, you'll see here. See, so you will get the common parts wherever the rows are matching, they will be concatenated. But if the rows are not matching, they are still included in the query result. But in the concatenation part, because now that you are concatenating two rows together, the number of columns increases in the query. So wherever it does not map, it cannot find a corresponding value in the next table, it will keep it as a null. So it will keep it blank, but it will still include all of the values from both of the tables. All of the rows from both of the tables would be included. Whenever they are getting mapped, in that case, both of the rows from both of the tables would be present, both of the values from each of the tables. When they are not getting mapped, from each table the value would be there, but their corresponding value, which should have come from the next table, would be blank. Okay. If you take the outer join here, just replace the inner with outer, and you'd be able to see what it is saying is syntax error at or near outer. Why? Did I do something wrong? No, inner, outer, the spelling is correct. It is. Postgres does not have outer, it says full outer. So you need to give it the full outer part. I feel that's what's wrong. That was what was wrong, I feel. Okay, what outer join did is, it's still in this table, maybe you're not able to see, or I'll say where, I'll give it a condition just so you can see. Okay, well, conference is null. So there will be tables where the conference is null. Why? Because the SQL was not able to find any mapping conference for that. But then there is also, that is the case here, that this is an ideal data set where everything is getting mapped and no other query, no redundant or left out data entries which are not getting mapped. But we'll always have such data. In real world, we do get data where entries don't get mapped. How would we include those entries in the column in our query result? So we'd be including them using the outer join. which includes not just the mapped parts, but also the left out parts with blanks in them because it could not find how to map it. See, outer joins has everything, the middle part, the left out part, whereas inner join only has the middle part. Okay, let's practice it, or we'll go over one more concept, which is left join, right join. Now, what do they mean is, see, there was inner join where you would only getting the middle data. There was outer join where you were getting all of the data. So left join and right join are kind of their intermediate, a midway there. That is that you are getting the middle part, which is the mapped data, but you're also getting the left out pieces, left out entries which were not mapped from either of the tables. Okay. So like in left join, what happens is you get the mapped data where everything is mapped and you can get the corresponding rows from another table. But then there are left out places in both the left side table and the right side table. You have left out rows. What left join does is it includes the left out rows from the left table or from the first table when you're writing this. So this is the left part table, which occurs on the left hand side, and this is the right table, which occurs on the right hand side. When you say left join, what it will do is it will include the middle mapped part from both of the tables, wherever they are getting mapped and the condition is getting satisfied. It will also include the unmapped left out row entries from the left table. Okay. On the contrary, what right does is it will do the same thing. It will include the mapped part, which is common to both of the tables, and it will get all of those columns filled beautifully. But the left out entries from the right hand side table, that is the second table while writing a join, those left out entries would also be included in the result of a right join. Okay. I hope this was clear and not too much. We'd be practicing a little bit now. Thanks for the affirmation, Umesh. I really needed that because SQL joins are so overhyped. I mean, they are difficult. I'm not saying they're not, but let's try a practice problem and we'll conquer these skills. Don't you worry. Okay. So what it wants is write a query that forms an inner join between tutorial Crunchbase acquisitions table and the tutorial Crunchbase companies, but instead of listing individual rows, count the number of non-null rows in each table. Okay. So whenever we say count, does some deja vu happen? Back when we discussed group by and aggregate functions in, I think, the fifth episode of this series. Group by, yeah. Group by was fifth episode. So like day before yesterday. We have performed so many aggregate functions, count, max, minimum, average, sum. That is where this is from. Let's see if we are able to do it or not. So we have tutorial Crunchbase acquisitions and we have tutorial Crunchbase companies. What we need to do is we need to perform our inner join and we also need to find what are the non-null rows. Okay. So how do we write? First of all, we'll do select star and we'll have from clause. Now from clause won't have just one table. We'll have multiple tables. But first I need to find what is the relation between these tables. So let's first take a look at each of those tables. So acquisitions has, the data is getting loaded. It has lots of columns and it has an ID column, company name. Okay. And then you have Crunchbase companies. Okay. So I feel company name should be the, yeah. Let's run it and see. Permalink, name, homepage, funding total, status, country code, founded at. I feel name is the thing here, right? Name is the name of that company. And in the previous table we have acquisitions, we have that as company name. That's what I feel is the relation here. If you can figure out some other relation, please let me know in the chat box. But I feel it's company name here and name there. Let's perform our joins accordingly. So acquisitions I'll give and alias as A, and then I'll perform an inner join by writing inner join. Then I'll write my next table, which is Crunchbase companies, and I'll give it an alias C. Okay, so both of them I have reduced my headache by giving it an alias, a simple one letter alias. Now I need to specify the condition. The condition which I have figured out, again, this is not something which was given there. I just thought that this might be the condition. What I feel is that the company name in the table acquisitions, which is referred by A now, so A dot, and then we'll have company name is equal to the name in the table companies. So that I'll be referencing by the letter C. C dot company name. So name here. Let's see if it works. So inner join, everything is specified. We have some data. So yeah, which means that the condition which we gave worked, and it was able to map tables. So now you see you have more columns. Why? Because the rows from both of those were concatenated together. So each row had a set of column values, different columns, and those two rows from two different tables are now concatenated together wherever this condition matched. And now we have a long table. But we don't want it. What we actually want is the count of the non-null things. So count of the non-null parts. So let's just do count star first, see what it generates. Oh, it's taking quite some time to load, makes me think if I'm doing something wrong. I think permalink is common. Oh, okay. Permalink is common, is it? I feel permalink is some link for that company itself. So, but yeah, you could be right. And that's why it's taking so long. I don't know. Wow, it's taking a lot of time. Now it is saying that we have 1673 apparently. What the question specified was that we just don't need the simple count, but we actually need the count of the non-null values. And how do you check whether the values are null or not? So you will go on the basis of individual rows count in each table. Okay, so whenever we have each table, we know that we need to have some column name for both of them. So I'll say that so column name for my first table is company name, which is what I would count, because that's what, on the basis of that is my whole join calculating the result. So I'll say I want a company name as one count. So as some acquisition count. Again, I'm giving an alias, but to a new column count. And then I'm creating a new column, which is count of the companies. So c dot name as comp count. Let's see how different they are. We are calculating what is the count. Whenever we have non-null values, we cannot give it star. Why? Because star would consider all of the columns together and it might not give you the accurate value, because even when there's null in one column and there is no null in the other column, it will consider that the row is not empty and it will be counted as one. So whenever we want specific non-null values, we need to provide it with a specific column name. If you have not checked out that video, it'll be the 5th video in the series of this playlist, named by as group by. That's where we have discussed all these aggregate functions. I would recommend you check it out. Joins take a lot of time to process. It's getting on my nerves. By the time, if there's anything you want to tell me, yeah, it got processed. Okay, so it is saying that the count is same there, which is there are no null values. Let's see if that's what the answer is and if that is what it generates. Okay, the answer considers permalink as the relationship. So I was wrong. I might not be wrong completely though. Let's see if the results are any different here. But Subramaniam, you were correct. So again here you want that data subject matter knowledge. If you don't know how your data is stored and what are the relationships between columns, and then you would end up where I am. So don't be that person. But I feel like company name and name would also have hit. I don't know. Maybe there are different ways to link it. Or maybe I'm just wrong. Okay, no, see, they also have the same result as mine. So I was correct. I was not wrong. So Subramaniam, you and me both were correct. I don't need to be sad about it. Okay then. Let's go ahead. We have done inner join, we have done outer join, and we have learned about left join and right join. What they do is they will include the mapped data which satisfied the condition from both of the columns, and it will also have the redundant left out unmapped rows from either of the tables based on what the join is. If it is full outer, then it will take from both of the rows. If it is left, then it will take from left hand side table. If it is right, then it will take the redundant rows from the right hand side table. So that's it for today. Let me know if you have any doubts and I'd be happy to help and clarify them. There could be more than one column. Yeah, that's what I feel too, Subramaniam. Thanks for pointing that out, that there are other columns. I could not find that link. So this was a way for us to concatenate this row wise, like you were getting, the rows were getting concatenated. So you had something from this row and then you had something from the, I'll show it to you because visuals help best. Why is a working query? Oh, because I have full left join. Wow. Full left join. So you can have left join, you can have right join, you can have full outer join and inner join. You cannot have full left join. Don't be me. Now what we were doing is we were doing the concatenation or joining row wise. What was happening was these are the rows, these are the values from the one table, and then this was getting added like horizontally. So horizontally the rows were getting attached. Now there's another way to join two tables, but that is horizontally. That is, the next row would come here. Okay, so it would be the second row. That's how they'll be stacked. They'll be stacked vertically. So one on top of other. Here, one was to the left side or the right side of the other. But now they'll be on top of each other. That is implemented using union, and it is very important again. So I hope I'll see you tomorrow, same time. Here we'll come together and learn the concept of union. And we'll also be done with more than half of the 15 days of SQL journey. So be sure to check that video out, and I'll be happy to have you here. Yeah, Subramaniam, we will be doing self-join, but not just yet because I feel this was a lot of information overload for this class. So I don't want to just bombard you with information that you're not able to take in and practice. Take these limited concepts, get your hands on, learn something, apply it to certain conditions, and once you're done with it, we can go ahead and move to more topics. Self-join I will be covering, not today. So I hope that answers your question. If you all have any more questions, you can add it here in the chat box or in the comments, or you can tag me on Twitter with the hashtag 15 days of SQL. I hope you learned something out of this. I had a great time. Thank you for joining me. See you tomorrow.